Right, so last time we had a bit of a fiddle around with our new environment and organism classes, and we created an environment, we created some organisms, and then we actually created a population of organisms and then plotted them. And they included using this sort of function here. Not even a function, it's just getting all of the positions of all of the organisms in your population. Well, that's okay, but you don't really want to have to write this bit of code every single time, or even to plot it every time. Or I don't want to have to run this cell to create the population every time either. So I think what I'm going to do is I'm going to build all of that into my environment class. Okay, so let's think about what we're going to do here. We basically want to augment this class by creating a few additional functions that can create a population and also can plot everything we need in that environment as well. So I think the first thing I'm going to do here is I'm going to create another method within the class. This is my environment class, right? I'm not going to touch my organism class yet. And I want to, let's create population. Okay. And I'm going to put the self in there. And what I'm going to do is exactly what I did down here. I'm going to delete this in a second, but I want to get this line and do it. In fact, I'm going to write it out again, so I'm not going to get any troubles when I cut and paste, right? So I'm going to create a list called population of organisms that I create when I start the environment, or any other time I can call it. So that's going to be organism, which is referring to the class below. I'm going to pass it the environment I'm currently in, because that's if you look at this, the first parameter that this class takes is the environment. Well, the environment is the one I'm in already, so I just got to use self here. I'm not worried about parents yet, but I'm going to do that for x in self.n. I haven't defined self.n yet. So when I create the environment, I'm going to create it with a default population of 1. Okay, and the first thing I'm going to put in here is self.n equals n. So that means by default, my environment will try and create a population with only one organism in it. Okay, and in fact, it's not going to do anything because I haven't called this create population function yet. So to do that, in my init, I'm going to do self dot create population, open bracket, close bracket, and that's just going to make sure that it runs this. And actually, what I haven't done a proper job of that. I want to create another variable called self.population, which I can call at any moment, and this function is going to return population. This is an important line, this return, because when I run this function, it's going to create the population and then it's going to return it from this function and stick it in this parameter called self.population, which means at any point I can access my population from my environment class. I can do env.population. It will give me all of those organisms. Let's create another function here, which I'm going to call get org positions. Okay, and again, that's a self. And what I want this to do is I want it to do what it was doing below. Remember, I was trying to plot those positions. I want to get the position of every single organism in my environment, in my population. So for x.pos, in x.pos for x in self.population, and then I'm going to return org positions. Okay, so anytime I call get org positions, it will give me all of the positions in that of the organisms in that environment. If that makes sense. Let's just do a bit of a sanity check here and make sure this works. I've got that. I've got that. I don't think I've run this yet, so I'm going to run that there. Okay, so as a sanity check, I'm going to delete everything underneath here that I was doing earlier including the plot. And I'm just going to create a new environment. See if that runs to begin with. I got an error, and that's because x in self end. I need to use a range function within that. So it was here. It wasn't creating a list. Let's see if it does it now. Okay, so I create an environment. This time I do env.dict. I've got everything, but I've also got a population with an object in there as well. And if I run env.get org positions, there it is, open bracket, close bracket, it'll give me the position of that organism. Okay. Now I could, if I wanted to, feed in n equals 10 when I when I create that class, and that will actually create a population of 10. If I get the object's positions, then here I can see the positions of those 10 organisms. Okay. The last thing I want to do is I want to make sure I can plot. Let's create a new function called plot environment self, and I basically just want to create that figure and axis, and I want to first of all plot the food, and then second I want to plot the organisms. Okay, so the food here is going to be I'm just going to do ax.plot self.food pos. Okay, and also I'm doing it twice. Food pos, and then for this one I'm actually going to use org positions equals self.get org positions. So that will actually use that function above, and it will get those positions, and then I'm going to plot them. Okay, and if I run that, if I have to rerun that, create my new environment, and this time I'm going to do env.plot environment. Okay, eng is not, env, silly. There we go. Oh, it's plotted as a line, so I need to go back up here and just make sure I'm using that marker. And I can even do the color share. I think I'm going to do the food as green, and I'm going to do the organisms as red. Just a G and O in there. Plot it again. There we go. Right, so it's done exactly what we had last time, but I can call every time I create an environment. I could create a new environment then and plot that without having to write that script every time. Okay, so that was a kind of an extra video. I didn't actually discuss about moving the organisms or eating yet. I'll save that for the next one.